Hello there everybody. In this video, I gotta cover generics in Java. Generics, it's a concept. It's where you can write a class, interface, or method, and it's compatible with different data types. There's two things we need, a type parameter and a type argument. So with type parameters, it's a set of angle brackets with a letter inside, for example, T. Basically, this acts as a placeholder, and it gets replaced with the real type. Now, on the other hand, type arguments, with various objects and data structures, you'll see a pair of angle brackets with a type inside, such as a string, but it really can be anything. It can be an integer, or a boolean, really anything. Type arguments specify the type. We send arguments to parameters. Really, our type parameter is just acting as a placeholder. Anything that uses this type parameter, it doesn't know the data type that it's going to receive. It's set up to receive really anything, or a primitive using a wrapper class. Let me give you an example of where you already see generics being used. For example, array lists. To create an array list, we add a set of angle brackets after array list, and we have to specify the type. What is this array list going to store? For example, strings. We would write the data type of string. Let's say that this array list is named fruits. Fruits equals new array list, and then we need a set of angle brackets again, parentheses, semicolon. In modern Java, within the second set of angle brackets, you don't necessarily need to type the data type again. Java can infer that, so you can leave it empty. This is the diamond operator. We have an array list that can store strings. We have specified the type argument. And now we can store some strings within our array list. So let's take our array list of fruits, call the add method, and add a few names of fruits, such as an apple. Let's do two more. Apple, orange, banana. Currently, the way that we set up this array list, it's compatible with strings, because that's what we set the type argument to be. Now, if I set this to be integers, well, we can't store strings anymore, but we could store numbers. 1, 2, 3. That's fine. Let me change that back. Generally speaking, an array list data structure can store all sorts of different data types. But when we create one, we have to specify what we're storing. That's the type argument. It's because within the ArrayList class, we have a type parameter set up, a set of angle brackets with a letter inside. In many cases, you'll see T meaning type, for type parameter. So let's actually take a look at our array list. I am going to locate array list, jump to source. Here's the class for our array list. There's a lot of advanced Java in here. Don't worry about that. But what I want you to pay attention to is the type parameter that comes after the ArrayList class name. We have angle brackets and a letter inside. In this case, E, meaning element, because an ArrayList has elements of data. By using this type parameter, our ArrayList is set up to store elements of various types. We just have to specify what the type is going to be when we actually do store data. And in my example, we're using strings. But like I said before, we can change the data type of what we're storing. We just have to change the type argument. I'll store booleans. True, false, true. I don't know what that has to do with fruits, but I'm just trying to prove a point here. So now what we're going to do is actually use type parameters. So let's delete our array list. Using generics, you can write some logic within a class, interface, or method, and it's compatible with many different data types. So what we're going to do in this example is create a class of box. Class box. We'll be using a type parameter to store all sorts of different things within our box. We can store a string within our box, an integer, a double, a boolean, even more complex objects. So we will set up a type parameter with a set of angle brackets, then type T. T is a common convention, meaning type. Let's say that when we create a box object, our box is going to act as a container. We'll store a value inside. Our box is going to be a reusable class. We won't always know what the data type of what we're storing is going to be. So what we could do is set the data type to be T. Let's say that this variable is an item. We're storing an item within a box. With T, it does mean type, but I like to think of it as thing. We're storing a thing, an item, within our box. We don't know what this thing is going to be. But really, it means type, and that's not as fun. T, item. We don't know what the data type is. If it's always going to be a string, we could just set this to be a string. But what if somebody is storing an integer, an int? Or we can use the wrapper class of integer. We don't know what the type is going to be. Let's create a method where we will set our item. Let's say that this is public, void, it's not going to return anything, set item. We'll have one parameter. What's the data type of what we're receiving? Well, we don't know, so we're going to use our type parameter of t. T is the data type. It's generic. We will receive an item. Let's take this .item and set it to be the item that we receive. We'll create a method to get our item. Public. Now we're going to be returning an item. The data type is t, so the return type is also going to be t. We're returning a value of the t data type. We will create a method to get item. We will return this .item. We can put things in our box, and we can get things from our box. Alright, this class is done. Our box class is set up to be reusable. We can store all sorts of different things, so to say, within our box. We will attempt to create a box object. For now, let's say box equals new box. But there's one step that we're missing. We have a warning here. Raw use of parameterized class box. We need to set up a type argument. What are we going to be putting in our box? What's its data type? Our box class wants to know. So we will use a type argument. After the class of box, add a set of angle brackets, then type what we're going to store. So let's say we're going to store strings within our box. Values of the string data type. And then we do need the diamond operator after the second box. And we're good. We now have a box object. But it's set up to store strings. Let's add some items to our box. We've even created a few methods for this. Set item. Let's take our box, call set item, but we have to pass in a string. Let's add a banana to our box. And then we will get the banana from the box using the getItem method. And now I want to get the banana. Box.getItem. Here we go. We have our banana. We have successfully retrieved the banana from the box. Our box class is compatible with all sorts of different data types. This time, let's store an integer. We will use the wrapper class of integer, but we can no longer add a banana to the box because it's a string. I'll attempt to do so. String cannot be converted to integer. Unfortunately, bananas are not numbers, but I can add the number 3 to our box. We have the number 3 within our box. If I attempt to add a double, like 3.14, we get a warning. Incompatible types. Double cannot be converted to integer. So I would have to set the type argument to be double, to add doubles to our box. 3.14. Basically, with our box class, we're writing the logic of how a box works. You put something in, and you can take something out, and it's compatible with different data types. We just have to use a type argument when creating a box object. We have to let Java know what we're storing within it exactly. Alright, let me give you another example. Now with type parameters, you can have more than one type. We can have 2 or more different types. Usually the common convention is to use U after T. So we're going to create a new class. File, new, Java class. We will create a class of product. Here we're going to write the logic of how a product works. With a product, you have an item and you have a price. We will set up a type parameter. Let me zoom in. We'll have one type of T, and a common convention for the second type is U, because in the English alphabet, the letter U comes after T. If you had a third argument, that would be V by common convention. So we'll just stick with T and U. We will have a generic type of item and another generic type of price. We don't know if our item is going to be a string or a more complex object. Our price could be an integer, a floating point number, a double. We don't know, but that's why we're setting it up this way. Now we'll need a constructor. We will take our product, then set up some parameters. The data type of our item is T. T item. But if we're creating a product, we also need a price. The data type of our price is U. U price. This dot item equals the item that we receive. This dot price equals the price that we receive. Okay, let's do a test run. Let's go to our main Java file. Product equals new product. And again, we need those type arguments. So this time we actually need 2, because our class is set up to receive 2 type arguments, T and U. For our product, let's say that the first type is going to be a string, followed by a double. And then we need the diamond operator after the second product. Alright, now we have to pass in arguments to the class. Because we have a constructor, we have to pass in an item and its price. And with our type arguments, we set that up to be a string and a double. We have to pass in those types. For our product, let's say that it's an apple, and an apple is 50 cents. That's a double. Let's create 2 methods within our product class. We will create a method to get our item. Let's say public, we're returning an item. The data type is T, so we're going to return T. Get item. We will return this dot item. Then to return the price, let's say public U, because we're returning the price, it has a type of U, get price. Return this dot price. We have our product object. I'm going to take our product object, call the get item method. And this is going to return our apple. Or I could get the price. Get price. And that is 0.5. You can use string format, but that might be overkill for this lesson. Alright, let's create a second product. So we'll have product 1 and product 2. Now product 2 will use an integer instead of a double. And let's say that these are tickets, like movie tickets. Ticket, and the price will be 15 for $15. Let's take product 2, call the get item method. So we have our ticket, and we should have a price. Get price. The price of a movie ticket is $15. Alright everybody, so that is an introduction to generics. It's a concept where you can write a class, interface, or method that is compatible with different data types. Basically, we're writing the logic of how this class works, and it's compatible with all different types. You just have to set up a type parameter, and then pass in type arguments. And well everybody, that is an introduction to generics in Java. What's up everybody? So today I gotta explain hash maps in Java. Hash maps are a popular data structure. They store a pair of values, a key value pair. You have a key and a value associated with that key. The keys have to be unique, but the values can be duplicated. Hash maps do not maintain any order, but they are very memory efficient. When creating a hash map, we have to set up type parameters. We have to specify what the data type of the key is and its value. Here's how to create a hash map. We will type hash map, let's say map for short, hash map map equals new hash map. We'll need to import this class. It looks like we're missing something. Let's take a look. Raw use of parameterized class hashmap. If we take a look at the hashmap class, we have type parameter set up. There's 2 values. We learned about type parameters in the last video on generics. We can store any 2 types of values within a hash map. We have a key and a value represented by k and v. We have to send type arguments to the type parameters. When creating a hash map, we'll have to set up some type arguments. So after our hash map, we have to list the data type of what we're storing. These have to be reference data types. So let's say with our map, we're going to have products, an item, and a price. So for the item, that could be a string representation of our item. So for the price, we could do an integer, but I think a double would be better, because you can have dollars and cents. Then we also need to use the diamond operator after the second hash map. You don't need to state the data types again, even though you technically could. Java can actually infer what the data type is. So after the second hash map, add the diamond operator. And there we go. We have our hash map that we have named map. The way that we've set this up is that we've told the hash map class we're going to store a string as the key and a double as the value. So to put things in a hash map, we're going to take our map, call the put method. We're going to put something in the hash map. We've specified that we're storing a string, then a double. A string for the key, and a double for the value. So let's say we have a store, and in our store we sell produce. We will have an apple, and its price will be 50 cents, 0.50. To put something in a hash map, you use the put method. We have to pass in two values as arguments. Alright, let's add a few more things. We'll have an orange. An orange will be 75 cents, let's say. Then a banana. Bananas are pretty cheap. They will be 25 cents. Alright, let's take a look at our hash map. I'm going to show you what happens if we output our map directly. System.out.println our map, our hash map. And here's what we have. We have all the key value pairs printed within our hash map. We have a string and a double. String, double. String, double. Now with hash maps, the keys have to be unique. For example, let's say I try and put another orange within here. We'll attempt to add another orange, and we'll see what happens exactly. Put another orange within our map, and let's say that the price is 1 million Venezuelan dollars. Yes, oranges are very expensive in Venezuela because of inflation. So here's what happens if we have duplicate keys. You actually overwrite the previous key value pair. Our orange is now worth 1 million Venezuelan dollars. So do keep that in mind. Hash maps cannot have duplicate keys. If you put another key value pair within a hash map and it already exists, you'll overwrite it. But that's also good if you want to change one of the key value pairs. Let's add one more key value pair. Let's say a coconut. Map.put. We will put a coconut within our hash map. Coconuts are a little more expensive. They'll be $1. Let's print our map to test it. There's our coconut. Then we can remove an element. To remove an element, take your map, call the remove method. Here you're going to pass in a key. Let's remove our apple. Then print our map. There, the apple is gone. We have orange, banana, coconut, but no apple. So I'm going to keep that in, but turn it into a comment. To get the value associated with the key, you can use the get method. So let me delete this println statement. We will take our map, call the get method. Let's get the value with this key. Give me the value where the key is apple, is what we're saying. That would be 0.5, meaning 50 cents. Or we can get our coconut. The value associated with this key is 1, meaning $1. Alright, you can also check to see if a key or a value exists. Here's how. We'll use the contains key method. Take our map, call the contains key method, and then pass in a key. Is there a key of banana? That returns a Boolean, in this case true. Is there a pineapple? There is not. So that returns false. You could use this within an if statement. Here's how. We will check if, let me zoom in, if our map called the contains key method, and then pass in a key. Does our map contain any apples? Contains key apple. If that returns true, we'll output map.get, then we'll get our apple. This will give us the price. Else, if contains key is false, then we'll output something else. We'll output key not found. All right, let's test this. So we do have an apple. We've set this up to return the price. But let's say we are looking for a pineapple. Contains key pineapple. If we do find a pineapple, we will get the price. Currently, there's no pineapples within our map. Key not found. So that's how the contains key method would be useful. We also have the capability to check to see if a map contains a value. So we will take our map within a print line statement, call the contains value method, and then pass in a value. Is there anything that's $1? 1.00. This returns a Boolean, and that's true. Our key of coconut has a value of 1.00, $1. And you do have to pay attention to the data type too. If I were to pass in an integer, this does return false. You do have to keep that in mind too. That's how to check to see if a map contains a key and a value. You can return the size of a map using map.size. Map.call the size method. Currently, there's 4 key value pairs within our map. This will return the number 4. To get the size of a map, call the size method. All right, now the last thing that we're going to do, if we were to print our map, we're given this ugly formatting where we have a set of curly braces, then all the key value pairs, comma separated. This time, using a for loop, we're going to cycle through all the key value pairs. We will create an enhanced for loop. What we're going to iterate through is every key, and these have a string data type, because that's the way that we set them up. The data type of each element is going to be a string, which we will name key, colon, think of it as in, for every key in. Now, what we have to do is get all the keys from our map. And there's actually a method for that. A beginner's friendly way to get all the keys from our map, what we can do is take our map, call the key set method. This will return all the keys within our map, and they're iterable, so we can use them within a for loop. For every key in our set of keys, what do we want to do? Let's do the following. Within a print line statement, let's print our key plus, we'll list each product and its price. Key plus, maybe I'll add a colon, space, then pick a unit of currency. I'll pick American dollars. For every key, we need to get its value. So we can use the get method, plus map.get, pass in our key. By using an enhanced for loop, we can customize the output of the key value pairs. And I think this looks a lot better. We have each product, each piece of fruit, and its price, laid out in this format. You could technically use printf if you want to display 2 digits after the decimal, but that might be a little too much for this lesson. I want to keep it as simple as possible. Alright everybody, so those are hash maps. It's a data structure that stores key value pairs. The keys have to be unique, but the values can be duplicated. We have to specify the type for the key and its value. And well everybody, those are hash maps in Java. Alright, let's do this thing everybody. Today we're talking about enums. Enums is short for enumerations. They're a special kind of class. They represent a fixed set of constants. By using enums, they improve code readability and are easy to maintain. One of the major benefits of enums is that they're more efficient with switches when comparing strings. So basically, an enum is a special kind of class where we declare constants. Here's a demonstration. We're going to create a new class. File, New, Java class. We're going to select enum. Enum is a special kind of class. Sort of like how an interface is a special kind of class. We will create an enum of day. Public enum day. Within this Java class, we can declare some constants. What we're going to write is enum constants. A common convention for these constants is that all the letters are uppercase. So after the enum constant, we'll add a set of parentheses, then associate this constant with the value. So let's say that we're working with days of the week. Sunday will be the first day of the week. Sunday will have a value of 1. Let's do this with the other days of the week. Monday, parentheses, then a value. Monday will be the second day of the week. Then we'll just follow this pattern. End all these constants with a semicolon. Alright, we have our enum constants. They have values 1 through 7. We're receiving some warnings here. Expected 0 arguments but 1 found. What we need to do is create a constructor. A constructor for our day class. When we define these enum constants, we're automatically going to call the constructor for this enum class, and then pass in this value. Let's create a field of day number for days of the week. We'll make these values private. We'll use the private access modifier. We don't want the ability to change them. We'll make them final. These are integers, that's the data type. We'll name these values day number. When we define these enum constants, we're automatically going to call the constructor and then pass in this value to the constructor. For the parameters, we'll have int, then our field of day number. This dot day number equals the day number that we receive. If you would like, you can add a getter method to actually get the day number. We'll use the public access modifier. We're returning an integer. We'll define a method of getDayNumber. And we will return our field of this dot day number. Alright, and we have set up our enum class. Reading and understanding these enum constants is a lot easier than these numbers. If I was looking at the number 5, I would have trouble understanding that that means Thursday. Now, how do we work with these enum constants exactly? Here's how. Within our main Java file, we will create a day object by using this enum class. Let me delete this. Day, rather than saying new day, and then passing in a number like 1, there's a different approach. We will access the day class, dot, and then specify a constant, a day of the week. Let's say Sunday. Remember that this is all caps. Our day is an object. Let's output our day and see what it outputs. This will output Sunday, all caps. If you would rather get the day number, the value that's associated with this enum constant, then we can use that getter method. Day.getDayNumber. So we have Sunday and 1. Where this is really going to be helpful is when working with switches. Here's a demonstration. We will actually use an enhanced switch. What are we examining? We're examining our day object. If our day matches a case of Monday, now this isn't a string. If this were a string, we would enclose this within a set of quotes. But using enums within a switch is actually faster than using strings. If it's Monday, then we'll output the following. We'll use an arrow, because this is an enhanced switch. Then we'll output, it is a weekday. Then if we have a case of Tuesday, let me just copy this. Tuesday will also output, it is a weekday. You can actually combine these cases together too. You just have to comma separate them. So case Monday, comma Tuesday, do this. Then let's do this with the other days of the week. Just for readability, I'll put these on new lines, each of these cases. So we have Wednesday, Thursday, Friday. These are all the weekdays, Monday through Friday. Then if we have case Saturday, then it's the weekend. case Saturday, we'll do the following. Output, it is the weekend. And we will also add a case for Sunday. So currently our day is Sunday. That will output, it is the weekend. If it were, let's say, Wednesday, then instead we output, it is a weekday. If we were comparing strings, all these cases would be enclosed within a set of double quotes, kind of like this. But we don't need to do that. It's actually more efficient to use enums. For some practice, what we'll do this time is accept some user input. We'll need a scanner. Scanner equals new scanner. Pass in system.in. Import this class. Be sure to close your scanner because I tend to forget. Scanner.close. Then we'll need a prompt. We will output the following. We'll use print rather than print line. Enter a day of the week. We will create a string variable, let's say response, equals, use our scanner, call the next line method. All these constants are uppercase. We'll method chain the to uppercase method to make our user input uppercase. When creating a day object, by using the enum class, we will use our response. We will use the value of method, and then pass in our response. Now we should be able to type in a day. Enter a day of the week. I will type Monday. It is a weekday. Let's run this again. I will type Sunday. It is the weekend. What if we type in a day that doesn't exist, like pizza day? Well, we get an exception, an illegal argument exception. We can catch that exception using a try and catch block. Any dangerous code we're going to enclose within a try block. We will try this dangerous code. And catch any exceptions. We will catch that illegal argument exception, which we will name E. If the user input doesn't match one of these enums, then we'll output the following. Please enter a valid day. Let's try it again. Enter a day of the week. Let's try Tuesday. It is a weekday. Saturday. It is the weekend. Pizza day. Please enter a valid day. Pizza day is not one of our enums, but if we wanted to change it so it was, we can add that. Pizza day will be the 8th day of the week. At least it should be. We'll need a case for pizza day. Pizza day will also be part of the weekend. That just makes sense to me. Alright, let's try that again. Enter a day of the week. Pizza day. It is the weekend. Alright. Alright, everybody, so those are enums, meaning enumerations. They're a special kind of class, kind of like how interfaces are a special kind of class. They represent a fixed set of constants. They improve code readability and reliability, and where they're really useful is when working with switches, because when working with switches, using enums is faster than strings. If I wasn't using enum constants, I could use integers, which are also efficient. But as a programmer, this is way less readable for me. At first glance, I would have no idea what these numbers are. But if they're enum constants, this is perfectly readable to me. These are days of the week. That makes sense. And well, everybody, those are enums in Java. What's going on, people? In this video, I'm going to teach you all about threading in Java. Threading allows a program to run multiple tasks simultaneously. It helps to improve performance with time-consuming operations, such as file input-output, network communications, or any other background tasks. Any code that is considered time-consuming, we can have it run on a different thread, so that it doesn't inconvenience our main program. There's two options to creating a thread. Option 1 is to extend the thread class. This is the simpler option, but it's limited. Option 2 is to implement the runnable interface. This option tends to be better, because by extending the thread class, we're limited to single inheritance, but by implementing the runnable interface, that's one way around that. In this demonstration, I'm going to show you option 2. It's actually not that more difficult than option 1, and it gives you more possibilities. I'll give you a demonstration of why threading is useful. In this program we're about to write, let's say it's a game, or a quiz or something. A user has 10 seconds to respond, and if they don't, time's up. Currently we have one thread. We're running our program on what is known as the main thread. Without using any other threads besides the main thread, I might write my program something like this. We'll start with the scanner because we'll be accepting user input. Scanner equals new scanner. Pass in system.in. Import this class. And close your scanner when you're done with it. Scanner.close. We're going to let a user know that they have, let's say, 5 seconds to enter their name. You have 5 seconds to enter your name. We will create a prompt. Enter your name. I'll use print rather than print line. We will assign a string variable of name, use our scanner, call the next line method. And then once we have the name, we'll output hello plus the user's name. Hello plus name. So let's do a test run. Currently we don't have a timer set up. You have 5 seconds to enter your name. I can type in a name, hit enter. We display hello the name, and then the program exits. Processed finished with exit code 0. If we were creating some sort of timer, we could do the following. To make this simple, we could use a for loop. The for loop is going to cycle 5 times. We will have an index of I. Int I equals 1, that's where we'll start. We'll continue as long as I is less than or equal to 5. And then increment I by 1. During each cycle of the for loop, to mimic waiting for 1 second, you can access the thread class, call the sleep method, pass in 1000 milliseconds. When you use thread, that refers to the current thread that we're working with, in this case, the main thread, which is what our main program runs on. But since our thread might be interrupted, we do need a try and catch block, because this is considered dangerous code. We will try this code, where we will have our main Java thread sleep for 1000 milliseconds. And we will catch the following exception, an interrupted exception. So within our catch block, we will catch any interrupted exceptions, which we will name E. If our thread is interrupted, we will say, thread was interrupted. In our imaginary timer, we'll need an exit condition. Let's say if our index of I is equal to 5, that means time's up. So we'll output time's up. I'm going to show you why this won't work the way that we think. We have 5 seconds to enter our name, but there's no prompt or anything. Then we get the message time's up, and only after that loop is complete are we allowed to enter our name. And then we can type in our name, we get the output of hello our name, and then the program exits. So the problem that we're running into is that all of this code is running on our main thread. We have 5 seconds to enter our name, but we can't reach that code until the 5 seconds are up, because our main thread is waiting for this loop to finish. So what we could do is create a separate thread where we're counting to 5, and our main thread is going to be in charge of accepting our user input. So here's how to create another thread. We're going to extend the runnable interface to create a runnable object. Let's go to File, New, Java class. This will be a class. We'll name this class myRunnable, or something unique that's relevant to what you're creating. MyRunnable is going to implements, because we're working with interfaces, the runnable interface. If you implement an interface, it's kind of like you're signing a contract. we have to override any required methods. We need to override the run method. We need the @override annotation. Then we will override the run method, public void run. Within this run method, we're going to add any code we want to run in the background on a separate thread. Going back to our main Java file, we're going to cut this loop and then paste it within the run method. When we call this run method, we'll have this countdown timer running in the background on a separate thread. Any code you want to run on a separate thread, place within the run method. Alright, going back to our main Java file, we'll tell the user they have 5 seconds to enter their name. We have our class of myRunnable. We will create a myRunnable object, or whatever it is that you named this class. Let's say myRunnable will be the name of the object, equals new myRunnable. We will take this runnable object, pass it into the constructor of the thread class. Here's where we're going to create a new thread. Thread equals new thread. Pass in your runnable object as an argument to the thread constructor. Now we just need our thread to start. You'll take your thread, call the start method, and this should work. Let's try it. You have 5 seconds to enter your name, and we get that prompt of enter your name, but I'm not going to type in anything. We get the message time's up because we ran out of time. Let's try it again. I'll type in my name this time. There we go. We get our output, hello bro. Then we get the message time is up. Both these threads are running at the same time. The code within our run method is running on a separate thread. It's running in the background while our main program is running. So that's why threads are useful. So let me extend this time. Let's say 10 seconds. If I is equal to 10, just to give us some more time. You have 10 seconds to enter your name. Now, check this out. You have 10 seconds to enter your name. I'll type in my name immediately. We get the output, hello, whatever your name is. But the program is still running because that second thread is still running in the background. Our program doesn't exit until all threads are done. If your main thread is done, you can end all other threads, but you'll want to set those threads to be what is known as daemon threads. A daemon thread will end when the main thread is over. We will take our thread, call the setDaemon method, pass in true. This thread is going to end as soon as our main thread is finished. Let's try it again. You have 10 seconds to enter your name. I'll type in my name. We get our output, and then our program exits without saying time is up. Processed finished with exit code 0. That's because we set our second thread to be a daemon thread. It ends when the main thread is over. Now, on the other hand, let's say that we wait for time to be up. We wait the full 10 seconds. Time's up. Our program isn't over yet. We're still waiting for user input, and I can still type it in. Hello, bro. Processed finished with exit code 0. Optionally, what you could do to get your program to exit, go to your runnable class, wherever you would like your program to exit. When seconds equals 10, that's where I would like to exit. To exit the program prematurely, I can access system, call the exit method, pass in an exit code of 0. That will end the program. Alright, let's try this again. You have 10 seconds to enter your name. I'm not going to type in anything. I'm just going to wait for the full 10 seconds. Time's up, and then our program exits. But that's what we want, though. The way that we've set up this program is that we want this program to exit either when we finish typing in our name, or we run out of time. Alright everybody, so that is an introduction to threading. It allows a program to run multiple tasks simultaneously. It helps to improve performance with time-consuming operations. It's useful with file input and output operations, network communications, or any other background tasks. And well everybody, that is an introduction to threading in Java. Yo, we finally made it to multithreading in Java. Multithreading enables a program to run multiple threads concurrently. at the same time. As we've talked about in the previous lesson, a thread is a set of instructions, and they run independently from other threads. Multithreading is useful for background tasks or other time-consuming operations. In the prior lesson, we've learned that there's two ways to create threads. We can either extend the thread class or implement the runnable interface. The second option is better in most cases, because we're not limited by single inheritance. Here's how we can get started multithreading. We're going to create a new class, File, New, Java class. We'll call this class myRunnable. MyRunnable will implements the runnable interface. If we're implementing an interface, it's kind of like we're signing a contract. We have to override any required methods. We have to override the run method. Public void run. Whatever's within the run method, this is the code that's going to perform when this thread is up and running. So what would we like to do? Just for a beginner's example, let's count to 5 using a for loop. We'll write a for loop. We will create an index of I. I'll set that equal to be 1 right away. We'll continue as long as I is less than or equal to 5, because we're counting to 5. Then increment I by 1. During each cycle of this for loop, I would like this thread to wait for 1 second before printing whatever I is, whatever the current count is, if we're counting. We will access the thread class, call the sleep method. Pass in 1000 milliseconds to sleep for a second. We will need to surround this method with try and catch blocks. We'll catch any interrupted exceptions. But let's output the following. We'll say thread was interrupted. After our thread sleeps for 1 second, let's display the current count. I'll just say I, just to keep it simple. Let's go back to our main Java file. We'll need to create a runnable object. MyRunnable. Let's say MyRunnable equals new MyRunnable. We have to pass in this runnable object to a thread object. Let's say thread equals new thread. We will pass in our runnable object. To get this thread to start, we have to call the start method of our thread, thread.startMethod. And this should work. We'll test it. 1, 2, 3, 4, 5. And then we exit the program. Another shortcut you can do too, instead of creating a named runnable object, we can pass in an anonymous runnable object to the thread constructor. So let's copy this section, delete this line of code, and then pass in a new runnable object. This will work too, and it's a lot more concise. Now, we won't have just one thread, we'll have 2. So let's rename thread as thread1, copy this line of code, paste it, rename the second thread as thread2, thread1.start, and thread2.start. So now we'll have 2 threads running at the same time. They're running concurrently. So they both say 1, 2, 3, 4, 5. We have successfully multi-threaded. You could differentiate these by getting their name. Here's an example. To get each thread's name, we're going to access the thread class, call the current thread method, and then method chain the get name method. Then I'll add a space plus our counter of I, just so we can see each thread by its name, and what it's counting exactly. Okay, let's try this again. We have thread 1 and thread 0. Now, they won't always be in the same order. They're running independently. Thread 0, that's our thread 1. Java's thread 1 is our thread 2. Okay, here's an exercise. We're going to have thread 1 say ping, and thread 2 say pong, like we're playing a game of ping pong. We'll modify the myRunnable class. We'll need some text. A text variable. We'll say private final, we don't want it to change, string text. Then we'll need a constructor to assign it. MyRunnable will have one parameter, a string of text. We will assign this.text equals the text we receive. Instead of printing our counter, we'll print our text. Alright, and that's all we need. Going back to our main Java file, we have to pass in some text when we construct a runnable object. For the first thread, we'll say ping. For the second thread, we'll say pong. So here's what we have currently. Pong, ping. And then we exit the program. Before we start the threads, let's say game start. There's one more thing I want to show you. Game start. After we start the threads, let's try and say game over. Game over. Here's what happens. Game start, game over. And our two threads are still running. Then we finish. So the problem here is that in our main thread, it doesn't wait for thread 1 and thread 2 to finish. Our main thread ends immediately. We can have our main thread wait for these threads to finish by calling the join method of each thread. Our main thread will wait for these two threads to finish. After these two threads start, we'll use each join method. Thread1.join and thread2.join. And we do have to surround these with try and catch blocks. Try thread1.join and thread2.join. If our main thread is interrupted, we'll output main thread was interrupted. Okay, this should work now. Before we display game over, we're going to wait for our two threads to finish. Here's what we got. Game start, and we display ping pong. And we'll do that 5 times, and then display game over. Alright everybody, that is an introduction to multithreading. It enables a program to run multiple threads concurrently. A thread is a set of instructions that run independently. Multithreading is useful for background tasks or other time-consuming operations. And well everybody, that is an introduction to multithreading in Java.